just Farila binti Hassan, and today I'm going to present about the technology that are used in wind turbines. So basically, wind turbines work on a simple principle. Instead of using electricity to make wind, like a fan, wind turbines use wind to make electricity. Wind turns the propeller-like blades of a turbine around a rotor, which then spins a generator, then creates electricity. The terms wind energy and wind power both describe the process of which the wind is used to generate mechanical power or electricity. This mechanical power can be used for specific tasks such as grinding grain or pumping water. Or even a generator can convert this mechanical power into electricity. A wind turbine turns wind energy into electricity using the aerodynamic force from the rotor blade, which work like an airplane wing or helicopter rotor blade. When wind flows across the blade, the air pressure on the one side of the blade decreases. The difference in air pressure across the two sides of the blade creates both lift and drag. The force of the lift is stronger than the drag, and this causes the rotor to spin. The rotor connects to the generator either directly or through a shaft and a series of gears that speed up the rotation and allow for physically smaller generator. This translation of aerodynamic force to rotation of a generator creates electricity. The majority of wind turbines can be divided into two basic types. The first one is the horizontal axis turbines. The second one is the vertical axis turbines. The horizontal wind turbines are what many people picture when they're thinking of wind turbines. Horizontal axis turbines have blades like airplane propeller, and they commonly have 3 blades. The largest horizontal axis turbines are as tall as 20-story buildings and have blades more than 100 feet long. Taller turbines with longer blades generate more electricity. Nearly all the wind turbines currently in use are horizontal axis turbines. Therefore, the vertical axis wind turbines come in several varieties, including the egg beater style Darius model. The vertical axis turbine have blades that are attached to the top and to the bottom of a vertical rotor. The most common type of vertical axis turbine is the Darius wind turbines, named after the French engineer Georges Darius, who patented this design in 1931. The wind turbines look like a giant two-bladed egg beater. Some versions of the vertical axis turbines are 100 feet tall and 50 feet wide. Very few vertical axis wind turbines are in use today because
Wind
they
turbine
do
have
not
5 components. The first one generator, the second one the tower, the third one rotor hub, and next gearbox, and the last one the blade. So let's go. We check all these components, what material they use, and how they made it. So let's go. We check it out. This one a generator. Electric generator in wind turbine are basically made of a rotor and a stator, and material used include magnetic steel and copper. This is for wiring in electromagnet generator or steel, copper, boron, neodymium, dysprosium in permanent magnet generator. And this one how they made the tower. Most large tubular steel wind turbine really on steel for its tower. Manufactured in section of 20 to 30 meter. This increase the tower strength and safe material. The advantage of steel in this tower is to provide strong enough base to support the height and the heavy weight of the turbine. Currently, the tower components are transported using a variety of different modes, including ship, rail, and truck. Next, this is a rotor hub. The rotor hub is the component that usually hold the blade and connect them to the main shaft to the wind machine. It's a key component not only because it holds the blade in their proper position for maximum aerodynamic efficiency. It's also rotated to drive the generator. Wind turbine hubs are traditionally made from cast iron that due to the atomic weight severely limit the overall production capacity of large-scale rotor. And then for this one, this is a gearbox. Usually wind turbine gearbox are made of steel, aluminum or brass. Other material may also be used. All wind turbine gearbox type have their unique form and special features. For example, multiplier gearbox made from steel and copper. This video show you how they made a wind turbine blade. Instead of using cloth to catch, the wine-like-proof blade and the ancient Iranian, today turbine blades are built from composite material, other blades from glass fiber, newest one from carbon fiber. Such composite material might be light and strong, but they are also extremely hard to recycle. Wind turbine blade just like an aeroplane wing. Wind turbine blade work by generating lift due to their curved shape. And then the side with the most comfortable low high pressure, while high pressure air beneath pushes on the other side of the blade shaped aerofoil. This is how they make a shape of carbon fiber into the wind turbine blade. Overall, wind turbines are predominantly made of fiber reinforcement, resin, core material, adhesive, and then coatings. The cost for a utility scale wind turbine range from about 1.3 million to 2.2 million. Do you know? One wind turbine can be installed in about 2 months. Why? The part that takes the longest to make is the foundation. And then this requires 28 days to set after being poured. For the last one, we know wind turbines are large, heavy, and extremely difficult to transport. Typically, in a traditional road planning, the fastest, most cost-effective road is chosen. Currently, wind components are transported using a variety of different modes, including ship, rail, and truck. So that's all for me. Thank you.
Wind turbine use the wind to make electricity. Unlike fans that use their blade to push the air and spin the blade of the wind turbine. When the blade turns, this causes the shaft inside the turbine to rotate. The shaft is connected to the generator, making it spin. The spinning generator creates lots of electricity capable of powering thousands of clothes, but the turbine or the product electricity. When the wine is blowing in order to solve this problem, electricity is stored in devices such as large batteries. Use of full power wine convert is increasing due to the installation of more and more offshore wine turbines. Onshore turbines with full converters are also increasing compared to DFIG-based wine turbines. Turbines this make the ratio between partial and full converts change to roughly 50/50. Pros and cons of both converter topologies. On the one hand, the double feed induction generator is mainly used on onshore wind turbine. The overall wind turbine cost is lower and can meet existing grid codes. However, maintenance is more expensive and turbine power levels are limited to a maximum of 6 MW. At present, on the other hand, the permanent magnet synchronous generator can be used on onshore and offshore. Turbines has an optimized system performance and it easily scalable to meet higher power level. The downside is that no cells weight increase as the turbine power level increase and cost is higher than the FIG turbine. The requirement for both onshore and offshore wind application, high power density, high reliability and robustness, long life time and excellent system efficiency.
Hi! What is the correlation between physics theory and the largest wind turbine? The basic ideas of wind turbine is related to the concept of energy. A wind turbine basically converts the wind's kinetic energy into electrical energy. This is because all wind is small particle each having kinetic energy. Wind power or wind energy is the use of wind to provide mechanical power through wind turbines to turn electric generator for electrical power. The basic equation for wind power is half rho AVQ. The kinetic energy of a mass with the velocity is half mv squared. The more dense the air, the more energy the turbine receives. The density of the air varies with altitude and temperature. Higher evolution has less dense air than lower evolution, and warm air has less density than cold air. The air mass can be determined from the air density and the air volume according to m equal to rho v. Then, into electrical energy via a generator because a generator can convert mechanical power into electricity. Power is energy divided by time, and the wind power is given as the wind power increases with the cube of the wind speed. To put it another way, doubling wind speed results in 8 times the wind capacity. As a result, choosing a windy position for a wind turbine is important. The effective available wind power is lower than the above equation indicate. No air could follow if the wind speed behind the wind turbine was 0. As a result, only a fraction of the kinetic energy can be recovered. The wind speed before the wind turbine is larger than after. The area A2 after the wind turbine is larger than the area A1 before the wind turbine, since the mass flow must be constant. The difference between the two wind powers is the effective force. That's all from me. Thank you.